It's been a minute, but I've been coding a lot of Rust. And today I want to share some of the event model patterns I've been using. We start with a quick overview of the different Rust channel types. Then we look at the crate I'm using now, which supports both async and sync and is very performant. And finally, we will walk through my 3-level patterns I've been using. And best of all of that is in the Rust 10x repo, which can be used by your AI to follow the best practices. So the most popular kind of channel type is the MPSC, which is multiple producer, single consumer. And basically you have multiple producers over there, which have their TX, their sender, and then you have a consumer, which has a RX, which is going to loop through all of the events. And then when you have a TX that sends an event, it will get picked up by the loop. And now you can send multiple events from multiple producers, and then the consumer will take one at a time. And so that is the responsibility of the channel to make sure that we have the queue here, and that if there's too many events, so in this case, this one is not yet picked up, then this one will hold back until there's room in the queue. So that is often called back pressure in a way. So now we can do that, and then that will get picked up like this. And so this is a very common system. So that allows us to have multiple kind of thread or task sending to one loop that gets the work. I use that a lot, for example, in TUI, Terminal User Interface, because that will be on my TUI side, and that might be my keyboard listener, that might be my data listeners, and all of these kind of things that will then send events over there. So that is the way it works. Now, the second type, which is a little bit less used, but is still used, which is a multiple producer, multiple consumer. So this one is very similar, but now you can have any numbers of consumers and obviously any numbers of producers. And now when an event comes back, same thing, get picked up by one. But then if there's multiple events, then it will be fan out. So it's very important here. It's not broadcasting, yes? So that events will go to one, and then the other one that come after, because this one is running, will go to another one. And different implementations have different kind of fanning strategy. Now, the next one is the SPSC. So in the SPSCs, we have a single producer, single consumer. So much simpler, you have only one guy over there, send the event get picked up, same model as everything else, and then if there's multiple events, then it will get picked up one at a time. So that is the RX. Now, the same strategy over there, if there's too many events, then the next one will wait over there until there's room in the queue. So that is the way it works. Now, the reason why that is useful, we can say, well, why is this code is not calling directly this code? Well, because this way, this code doesn't have to know the threading model in a way of that code over there. It can just like send events and not worry about what is happening. Now, the next one is what we call the one-shot. And the one-shot here is basically different than the SPSC, which is now we have a sender. But when we send the event, the sender gets consumed. The event moves to the queue here, kind of, and then get picked up, and then even the RX get consumed. So that is just one shot. And then after we can create a new one shot, obviously, and that will consume everything. But at the end, nothing is left. Now, what we use that quite a bit when you want to have a kind of a model, for example, MPSC, and you want to send an event. But in this event, you want to allow your code over there to ping back the code that have been sending it and to say, hey, the thing has been done, or here's a result or everything. So you can mimic an RPC call with an event base, which is one shot. You just put a one shot over there, which is reversed, which will point over there. So now when the event will go there, we'll go to my code over there, and my code will say, okay, I do the work, and then I will send back the one-shot over there. So that is basically a good use of the one-shot architecture inside the MPSC. Now, the big question is which crate to use for Rust channels. Tokio has some built-in channels, but they are only async. And the trick here is I like to have my TX and even RX, but RX is okay if I'm only async or whatever. But my TX, sometimes I don't want them inside an async. Or sometimes I'm stuck in a case where it doesn't really fit the async model. Typically, what I've done is I've used Flume, which was an amazing crate, and I've been using that a lot for many of my coding. Now, the trick of this one is that to the latest, and I don't see it here, but it was put not in maintenance mode, but in kind of in a slow mode, kind of a hold on mode. And there's a new crate that I'm a big fan of, and that is Crossfire. And then this one is actually amazing. It's highly performant, so it takes the best of Crossbeam in a way, but it's doing a lot of optimization over there. And you can see that compared to any kind of channels, they are just crushing it. So this is very good. And then one of the good things about this is that when you have these different type of channels here, for example, SPSC, there's a lot of optimization you can do if you code it correctly. And this is what Crossfire has been really spending time. When you put SPSC, they are using techniques that wouldn't fit in the other ones, but make the SPSC extremely efficient. So that's why now I'm using a lot Crossfire in all of my stuff. So now, how am I using it? This is where my 3-level patterns comes in. The first level here is the lib wrap. And the lib wrap is all about wrapping the libraries that I'm using. So here I'm using Crossfire, and I'm wrapping it into my own type over there. So this way, this is what I'm going to expose to my application code. And I'm not going to expose the internal of Crossfire. That allows me to wrap the APIs the way that I want. So for example, in my case, I like usually to have async first. So when I do a receive or a send, they are async. And if I want to have a sync, I do _sync. So that is the style that I like to have in my application code. And this is what this allows me to do. Now, also one thing that I like to do is to name my channels with a static string. It doesn't have to be dynamic. I don't want it to be dynamic actually. But this way, when I report error, when I cannot send to a channel and everything, this is very helpful. So when I create a new, so I have my own factory of channels, and it's just a little wrapper on top of Crossfire, and I make sure that they always take a name. So like this, I can do that. So that is the level 1. Now, the second level is the type alias. And this one is very lightweight. But for example, when I am my TUI, for example, I have a TUI event over here. And then I have a type alias, which is going to be TUI TX and TUI RX. So this way is cleaner in the code. I just have those. It's not very hard type, because I can still use that and that will work actually. But it's a nice way of having a clean code over there. Now, the third level here that we have is the type wrap. Well, now I wrap my own type. And so that means that now, for example, I have an AI job RX, and I have my own function here. In this case, will be a next request. And this is useful sometime when I want to have a domain APIs for a construct. Sometimes it might not even be RX, might be Q or something else, whatever means. But it's also nice when I want to expose my libraries to the outside world, such as I don't have to expose the internal of level 1, for example, because in this case, I still have the send and everything. But now I'm going to expose that guy, which is going to be a very targeted domain construct, such as the external library can use mine. So that is the 3 levels that I have. Now, here's a cool thing. If you go to GitHub rustnx/rustnx, I put this repo, and now you have a folder which is pack. And that is all of the best practices that I have in my videos, many of them, and now even the sample code. So for example, in the guide, we have all of the base guides. And all of this is a guide that I have in many of my videos here. We have the examples, we have the best practices about the error, we have the fluid builder pattern. So you can give that to your AI and it will follow the best practices. And it's actually what I'm doing with AI Pack and Procoder. And now under Pack as well, you have samples. And here I actually put some code, such as we can have the whole example here. For example, in the event-based, I give the AI and myself all of these patterns here. So that is a level 1, basically. And if we go to the source over there, we're going to see that we have the level 2, which is this example here, which is TUI. So this is just a kind of a fake project in many ways. But if we go to the AI jobs, that would be a level 3. So that is a little bit the way it works. And I do that for things that needs a little bit more code. Otherwise, in guide, you have it in domain, and in event, you have the design over there. So you go to design, and now I have things where I like to have a little mermaid diagram over there, and then I have all of the specs there. So that you can give that to AI again, and that will work very nicely. And in fact, I have a code map. So that is what I'm using in AI Pack Pro Coder, and that is going to be what is going to be used in Decoder as well. So now this will tell when to use each files, the summary, and then the public types and public function. And that is a gem when you work with AI. It's amazing. It's part of my auto context pattern. I'm going to do a video on that later. Until next one, happy coding.